You might imagine the cosmos as a realm of quiet beauty, of distant suns and swirling nebulas that tell stories of creation and calm. But far beyond the familiar glow of constellations, the universe holds some of the most ruthless, extreme, and unforgiving objects ever discovered. These are not the gentle stars we know. They are the crushed cores of dead stars, packed with the mass of our sun, into a sphere just 12 miles wide, spinning faster than a kitchen blender, and blasting radiation across the galaxy. Among these cosmic oddities, one stands out as a true predator, the Black Widow, Pulsar. Named for the venomous spider that consumes its mate after breeding, this celestial creature is a cold-blooded killer that slowly hunts, drains, and destroys its companion star without mercy. Today, we journey into the heart of this terrifying phenomenon, unpack its mind-bending physics, trace its violent life cycle, and reveal how NASA's most advanced telescopes have unlocked the secrets of the universe's most chilling stellar assassin. To understand the Black Widow Pulsar, we must first understand what a pulsar is. A pulsar is a highly magnetized, rapidly rotating neutron star that emits narrow beams of electromagnetic radiation from its magnetic poles. Think of it as a cosmic lighthouse, as the star spins its beams sweep across space, and if Earth lies in their path, we detect a steady pulse of light or radio waves. Neutron stars are born when a massive star, at least 20 times the mass of the Sun, runs out of nuclear fuel and collapses in a spectacular supernova explosion. The outer layers blast into space, painting the sky with glowing nebulas, while the core crumples inward under unthinkable gravity. Protons and electrons fuse into neutrons, creating a material so dense that a single teaspoon would weigh billions of tons on Earth. Most neutron stars spin slowly at first, but a special subset, called millisecond pulsars, spin hundreds of times every single second. For decades, astronomers could not explain how these stars reached such insane speeds. The answer we now know is cosmic cannibalism, and the Black Widow Pulsar is the most extreme example of this process. The Black Widow Pulsar is born in a binary star system, two stars, bound together by gravity from their very formation. One star is more massive than the other, so it lives a shorter, fiercer life. It burns through its fuel, quickly goes supernova, and collapses into a neutron star, while its smaller companion survives. For millions of years, the two stars coexist, peacefully orbiting one another in a quiet gravitational dance. But as the neutron star ages, its unimaginable gravity begins to pull at the outer layers of its neighbor. This is where the hunt begins. The companion star, usually a low-mass red dwarf, brown dwarf, or even a stripped stellar core, is completely helpless against the pulsar's pull. Tidal forces stretch and distort the companion, pulling gas, plasma, and stellar material away from its surface like a cosmic vacuum cleaner. This stolen material forms a hot, thin accretion disk that spirals inward toward the neutron star. As the material slams into the pulsar's surface, it adds angular momentum, spinning the dead star faster and faster, turning it into a millisecond pulsar. But this is not just a gentle transfer of mass. It is a brutal, one-sided destruction. Once the pulsar reaches millisecond spin rates, it unleashes a storm of high-energy radiation, gamma rays, X-rays, and relativistic particle winds that blast the companion star without pause. These beams heat the companion's facing surface to more than 12,000 degrees Celsius, twice the temperature of the Sun's surface, turning its outer layers into superheated gas that blows away into space. Over millions and even billions of years, the pulsar slowly eats away at its companion, stripping it of mass, bit by bit, layer by layer, like peeling an onion. Some companions are reduced to tiny, smoldering cores, less than 10% the mass of the Sun, barely clinging to existence. Others are completely devoured, leaving nothing but a lone, fast-spinning pulsar to drift through the galaxy. This is why astronomers named it the Black Widow Pulsar, just as the female Black Widow spider consumes her partner. To survive, this pulsar sustains and empowers itself by destroying the star that once shared its orbit. It is a cycle of survival that is as haunting as it is fascinating. The first Black Widow pulsar was discovered in 1988 using the Arecibo radio telescope in Puerto Rico. Designated PSR B1957+20, this object sits about 6,500 light-years from Earth in the constellation Sagittarius. Astronomers noticed a precise rapid radio pulse that occasionally vanished for short periods. Further observations revealed the signal was being blocked by a cloud of gas torn from a tiny companion star being eaten alive by the pulsar. This was the first concrete proof of a cosmic predator actively consuming its neighbor. Since that groundbreaking discovery, NASA's Fermi Gamma Ray Space Telescope has become our most powerful tool for hunting these hidden killers. Launched in 2008, Fermi is built to detect the highest energy light in the universe, and it has uncovered dozens of black widow pulsars across the Milky Way. One of the most extreme examples is PSR J1311-3430, a pulsar that spins 390 times per second and orbits its companion in just 93 minutes. Its companion is only 12 times the mass of Jupiter, heated to extreme temperatures, and slowly being eroded into nothingness. NASA's Chandra X-ray Observatory has also captured stunning images of these systems, showing the hot glowing plasma streams that flow from the companion to the pulsar, visual proof of this cosmic feast. Black widow pulsars are part of a larger family called spider pulsars, which includes redback pulsars, named for another venomous spider. The key difference lies in their companions. Black widows target extremely low-mass stars, often less than 5% the mass of the Sun, while redbacks attack slightly larger companions. Black widows are the more ruthless predators, their radiation more intense, their appetite more unrelenting. They are the apex predators of the neutron star world, silent and invisible, until their beams sweep across our planet. These systems are defined by their extreme orbits too. Some complete a full orbit in less than 3 hours, with the two objects separated by a distance smaller than the radius of our Sunday. It is a cosmic dance of death, played out in extreme speed and gravity. For astronomers and astrophysicists, black widow pulsars are far more than just cosmic horror stories. They are living, breathing laboratories that let us study physics under conditions impossible to recreate on Earth. The extreme gravity, magnetic fields, and energy in these systems test the very limits of Einstein's theory of general relativity. By measuring how these pulsars spin, emit radiation, and interact with their companions, we refine our models of stellar evolution, neutron star formation, and the life cycles of binary star systems. Every time a black widow pulsar strips material from its companion, it enriches the surrounding space with heavy elements that will one day form new stars, planets, and even the building blocks of life. In a twisted, poetic way, this cosmic killer plays a vital role in the cycle of cosmic creation and destruction that shapes our entire galaxy. The universe often reveals itself as a place of both breathtaking beauty and unyielding brutality. The Black Widow pulsar embodies this duality perfectly. It is a remnant of a star's violent death, yet it sustains itself by destroying another star. It is invisible to the naked eye, yet it emits some of the most powerful radiations in the cosmos. It moves with mechanical precision, spinning hundreds of times per second, yet its actions are as ruthless as any predator in nature. Our own Sun is a quiet, stable star, destined to become a gentle white dwarf, billions of years from now, no threat to any world around it. But for every calm star like our Sun, hundreds of Black Widow pulsars lurk in the dark lanes of the Milky Way, silent hunters waiting to strip their companions of life. As we wrap up this journey into the world of the Black Widow pulsar, we are left with a deep sense of awe at the universe's capacity for both creation and destruction. These cold-blooded cosmic killers are not just monsters in the dark. They are key pieces of the cosmic puzzle, helping us understand how stars live, die, and shape the galaxy around them. Every new discovery about these pulsars brings us one step closer to unlocking the deepest secrets of the cosmos. The next time you look up at the stars, remember, some of the most compelling stories in the universe are not told by the bright, shining stars, but by the dark, deadly remnants that hunt in the silence of space. They remind us that the universe is full of mysteries, both beautiful and terrifying, waiting for us to uncover them. Please like, comment, share, and subscribe to the channel.